Picture this. You're looking at two different subscription services, trying to decide which one to buy. Plan A has a really low monthly fee, but it costs a premium every time you actually use it.
Right, and Plan B has this massive upfront monthly cost, but the per-use rate is, like, dirt cheap.
Exactly. And if you are like most people, you'll look at your budget, make a gut guess about your habits, and just pick one. But what if I told you that a high school algebra Formula 1 you probably haven't thought about in 20 years can predict the exact mathematical second your gut instinct starts lying to you?
I mean, it's entirely true. We rely on intuition for so much of our daily decision-making, and, well, often that intuition is just mathematically flawed. We assume things scale in a straight line, or we misjudge where the breaking point of a good deal actually is.
So today we're taking a deep dive into a really fascinating book called Math I Reboot, Magic Carpet Ride Promotion. And our mission for this conversation is to completely dismantle the trauma, the fear, and the sheer frustration so many of us feel around high school math.
Oh, the trauma is very real for a lot of people.
It is. We are going back to the exact moment where math stopped being just counting apples and started being, letters, graphs, and weird conditions.
Which is the exact spot where a lot of learners just hit a brick wall. The moment you introduce abstract symbols, it can feel like you're staring at a wizard's spellbook. And if you don't already know the magic incantation, you just assume you don't have the gift for it.
But for you, the listener who wants to actually understand the why behind the way the world works, this deep dive is going to reframe everything. Math is not a wall of abstract rules designed to gatekeep smart people. It is simply a language meant to be read.
Right. It's a way of seeing the underlying structure of reality. And becoming fluent in a language doesn't require perfect confidence on day one. It just requires understanding the basic grammar.
Okay, let's unpack this grammar. Because the book starts by addressing those foundational tools that used to trip us all up on our homework. Numbers, algebraic expressions, and logic. And it completely changes how you look at a simple minus sign.
We're taught to just memorize the rule, right? Like a negative times a negative equals a positive. But we rarely pause to ask why.
Yeah, I definitely never asked why.
Most don't.
Yeah.
But the book points out that a minus sign isn't just a dash on a page telling you to subtract. It is an instruction about direction. It tells you about a position relative to a zero reference point.
It's navigating space, which helps explain one of the most classic, infuriating traps in early algebra. The difference between -3 squared, written without parentheses, and -3 inside parentheses, squared.
Oh yeah, that one catches everyone.
Without parentheses, the exponent only applies to the number 3. So 3 squared is 9, and then you apply the negative direction. You end up at -9.
But with parentheses, the exponent applies to the whole package. It's -3 times -3. So that's two reversals of direction, bringing you to a +9. It isn't a trick question designed by a cruel teacher. It's just syntax.
Syntax. Like it's the mathematical equivalent of punctuation. Let's eat grandma versus let's eat grandma.
Exactly. The parentheses change the entire meaning of the sentence. And that same linguistic logic applies to algebra. When we see letters like X or Y, we've been heavily conditioned to think of them as an unknown enemy, like a fugitive we have to hunt down and solve for.
The dreaded find X directive.
Right. But the book suggests a much more powerful way to view variables. They aren't just hiding a single secret number. They're tools for describing every possible scenario simultaneously.
The example from the text really clarified this for me. Let's say you're buying X number of notebooks, and they cost 120 yen each. The expression is 120x.
Right.
That X could be one notebook, or 5, or 10,000. The expression 120x is like a zip file that holds the entire universe of possible purchases in one incredibly compact package.
You're expressing a relationship, not just creating a hurdle for calculation. And once we understand how variables express relationships, we step into the realm of logic, specifically sets and propositions.
Oh, necessary and sufficient conditions. I remember just staring at these on logic tests and feeling my brain slowly melt.
They require a totally different kind of mental muscle. But the book breaks it down with a remarkably grounded example. Consider the statement, if it is raining, the ground is wet.
Okay, so in this scenario, rain is a sufficient condition for the ground to be wet. If it's raining out, that is entirely sufficient to guarantee a wet sidewalk.
Precisely.
But, crucially, rain is not a necessary condition for the ground to be wet. I mean, sidewalk could be wet because a fire hydrant burst, or a street sweeper drove by, or someone spilled a giant iced coffee.
Exactly. The logic only flows safely in one direction. And from there, the book introduces the converse, the inverse, and the contrapositive. The original statement is, if A, then B. The converse flips it to if B, then A, which, as we just established with the wet ground, is absolutely not a guaranteed truth.
Right, just because the ground is wet doesn't mean it rained. I have to push back slightly here, though.
Sure.
I understand the puzzle aspect of this, but does knowing the difference between a converse and a contrapositive actually matter in daily life? Or is this just for passing a test?
Well, let's pull it out of the classroom then. Because misunderstanding logical flow is arguably the root of most bad decision-making in society today.
Wait, really?
Oh, absolutely.
Yeah.
You see this flaw constantly in boardrooms, in political arguments, and in how we read news headlines. People universally assume that if A causes B, then B must imply A. They see successful people waking up at 5 a.m., and they assume waking up at 5 a.m. guarantees success.
They flip the condition without realizing the converse isn't automatically true.
Precisely. Waking up early might be a characteristic of a successful person, but it is not a sufficient condition to create success. Understanding the strict one-way flow of logic is a critical defense mechanism against being manipulated.
So logic gives us the strict, invisible rules of cause and effect. But we don't live in a textbook of invisible rules. We live in a physical, three-dimensional space. How do we bridge the gap between abstract logic and the physical world?
That is where we shift into geometry and functions. We have to learn how to translate a physical shape into a quantifiable number.
And the book starts that translation process with the right triangle, which honestly I always found weird. I assumed we spent so much time on right triangles just because the math was easier to grade.
It's actually foundational because the physical world operates on horizontal and vertical axes. Gravity gives us a perfect vertical drop, and the horizon gives us a flat plane. A right triangle allows us to map any diagonal movement or shape against those two unchangeable realities.
And that gives birth to trigonometry: sine, cosine, and tangent. 3 words that instantly trigger panic for anyone who struggled with high school math.
But the book completely demystifies them. They are not magic buttons on a scientific calculator that spit out endless decimals. They are just dictionaries. They are fixed ratios based entirely on the principle of similarity.
Let me make sure I have the mechanics of this right. If you take a right triangle and scale it up to be the size of a skyscraper, the internal angles don't change.
Right, they stay the same.
And because the angles don't change, the proportions of the sides relative to one another stay perfectly identical. So sine, cosine, and tangent are just names for those fixed proportions.
That's the mechanism perfectly described. And the famous angles we were forced to memorize, 30 degrees, 45 degrees, 60 degrees,
Yeah.
they aren't random numbers chosen to torture you. They are derived from incredibly intuitive shapes.
Right. The ratios for a 45-degree angle come directly from taking a perfect square and cutting it in half diagonally.
Exactly.
And the 30 and 60-degree ratios come from taking an equilateral triangle and slicing it straight down the middle. Once you visualize the physical shape being cut, you don't even need to memorize the chart. You can just mentally rebuild the shape.
You're seeing the structure. And once we can measure static space, we can finally start measuring movement and change. We step into functions, specifically the shift from a linear function to a quadratic function.
Well, a linear function is easy to picture. It's steady change. If I make $20 an hour, my total pay goes up by exactly $20 every single hour. It's a straight line on a graph. But a quadratic function, where the formula involves x squared, that behaves totally differently.
In a quadratic function, the way the value changes is itself constantly changing. Think about calculating the area of a square. If you double the length of the sides, the area doesn't double, it quadruples.
Oh, wow.
Yeah, and if you triple the side length, the area becomes 9 times larger.
So linear functions are like walking at a steady pace, but quadratic functions are like pressing the gas pedal. The speed itself is changing.
What's fascinating here is that viewing variables as moving quantities rather than static mysteries fundamentally changes how we interact with graphs. A graph is just a visible picture of a functional relationship happening over time.
But if a graph is just a picture of variables moving over time, how do we actually freeze frame that movement mathematically to analyze it?
That brings us to what I think is the ultimate aha moment of the book.
Yes. Showing how functions, equations, and inequalities are actually all telling the exact same story about a single shape, the parabola.
The parabola is the ultimate hub of high school math. And to master it, the book tackles the most universally dreaded process in algebra, which is completing the square.
I remember this as just pure algorithmic torture. You take a messy quadratic equation, your x squared plus bx plus c, and you execute this bizarre sequence of having the middle number, squaring it, adding it, subtracting it. It felt entirely pointless.
It feels pointless if you only memorize the what and not the why. Completing the square is actually a brilliant mechanical trick to find the exact center of gravity of a parabola. It shows us where the graph turns.
Because by forcing the messy equation into a format where a chunk of it is squared, you're exploiting a fundamental rule of numbers. Any real number, when multiplied by itself, is either positive or zero. You can't square a number and get a negative result.
Right.
So the absolute smallest value that squared portion can ever be is zero.
You've isolated the bottom of the bowl.
It's incredible. You aren't just moving numbers around to satisfy a teacher. You are mathematically hunting for the physical bottom of a curve.
And once you find that turning point, you can connect the equation to the graph. The quadratic equation is just asking, where does this parabola cross the x-axis?
And to find that out, we use the quadratic formula. But the book isolates one specific piece of that formula, the part trapped underneath the square root symbol. The discriminant, the b squared minus 4sc's part.
Yes. The discriminant isn't just an annoying calculation. It tells you the nature of reality for that graph. If that calculation is a positive number, it crosses the axis twice.
But if the discriminant is exactly zero, it touches it exactly once, a repeated root.
And if it's negative?
Well, you can't take the square root of a negative number in real numbers, so it never touches the axis at all.
Exactly. But why do we care?
Right, so what does this all mean? Why do we care so much about where a curve hits an invisible zero line?
Because zero represents the threshold of change. It's when a profit becomes a loss, or when one pricing plan overtakes another.
And inequalities play right into this. An inequality like greater than zero just asks, what part of this curve is hovering above the water? Like which part is above the x-axis?
It's a completely visual way to map out thresholds.
Okay, so we've mastered the theory of change and thresholds. Now let's bring it into the messy, real world where the listener lives making decisions and reading data. Back to those pricing plans we mentioned earlier.
Right, real-world linear modeling. Plan A is 120 yen per use plus a 500 base. Plan B is 80 yen per use plus a 900 base.
Math reveals that Plan A is strictly better for fewer than 10 uses, and they tie at exactly 10. Here's where it gets really interesting, though. Most people buy the subscription with the lowest base fee blindly, but this math proves the cheapest option is entirely conditional.
I completely agree, and applied mathematics requires choosing the right variable. In life, building the mathematical model is actually harder than the calculation itself.
Especially when you're doing data analysis, because as the book warns, averages can lie to you.
Oh, they definitely can. Two groups can average as 70 on a test. But what if one group has everyone scoring between 65 and 75?
And the other group has scores wildly spread from 40 to 95. The average is identical, but reality is totally different.
That is why you need tools to measure the spread from the center. You need quartiles, variance, and standard deviation.
Standard deviation always sounded so intimidating to me, but functionally, it's just measuring the unevenness of the data, like a broken thermostat that drops to 40 and surges to 100. The average is 70, but you're still going to freeze and then cook.
That's a perfect analogy. Standard deviation measures how violently the data swings. And we see this unevenness with scatter plots, too. We look for positive and negative correlation, but the ultimate warning is that correlation is not causation.
Just because ice cream sales and shark attacks both go up in July doesn't mean eating ice cream attracts sharks.
Precisely. And outliers matter, too. They tell a story that the average ignores.
We've looked at cold, hard data. But the book ends with a really poignant short story that applies the concept of data spread to the human mind and our own insecurities.
Yes, the story of Mahu Shiraishi. She's a student who scores a 62 on a math quiz and just feels she is bad at math. She internalizes that single number as her permanent identity.
But her teacher, Miyazawa-sensei, pulls her aside. And he shows her two sets of numbers. Both average roughly the same, but one is tightly packed, like 58, 60, 61, 62.
And the other is wildly spread out, like 20, 40, 62, 85. He uses standard deviation to show her that her 62 isn't a fixed identity. It's just a single data point in an uneven spread of understanding.
He gives her a practical four-step framework. 1, what is the problem asking? 2, what topic is it? 3, what expression or graph helps? And 4, return to the condition. It made me realize learning isn't a single data point, it's a box plot. We all have variations, strong points, and weak points.
If we connect these to the bigger picture, Feeling bad at math often just means you are unfinished, not incapable. You are learning to read a language, and fluency takes time.
So shifting our perspective from memorizing formulas to seeing the structure of logic, parabolas, and data, it really empowers us to make clear judgments in everyday life.
It absolutely does.
I want to leave you, the listener, with a final provocative thought from the book's appendix. It's designed for adult learners, and it's called The Shortest Review Route. And it suggests that adults shouldn't review math chronologically.
No, they shouldn't,
Yeah.
because adult brains thrive on connected systems rather than isolated stepping stones.
So instead, they should tackle the hardest structural hubs first, like quadratics and algebra. And it
Yeah.
makes you consider what other daunting subjects in your life might you conquer simply by starting in the middle, looking at the overarching structure, and rebooting your perspective.
It's a really powerful way to approach learning anything new.
It really is. Well, thanks for joining us on this deep dive.